Hello everyone, my name is Hossam Badruldin and I'll be proposing a new methodology for forensics data acquisition in public cloud IaaS deployments. This topic falls into the realm of public cloud forensics. This presentation on content has been prepared for the Information Systems 805 class in Dakota State University for fall 2018 session. Introduction. We propose a new methodology to collect forensic evidences from public cloud-hosted platform without involving cloud providers and by utilizing the available open source tools that can be used to acquire RAM and disk images from the most common public cloud platforms such as Amazon AWS, Microsoft Azure, and Google Cloud Platform. Problem identification and motivation. Cybercrime in the era of cloud computing have added another layer of complication for the existing lack of digital forensics, toolings, and techniques. While theories like Bayesian theory and Dempster-Shaver could be repurposed and adjusted to help solve digital crimes in the cloud, there is very little known information about their applicability to performing forensics in public cloud and in shared resource pools. Cloud service providers being involved in the forensics investigation and process suddenly may raise a question related to the maintenance of chain of custody of the collected evidence. Furthermore, there is a major lack of digital forensic tools that are available to perform cloud forensics, and more specifically, digital cloud forensics on the public cloud. Objective of the solution. We have chosen a problem-centered approach to come up with a solution. The solution we developed is a new methodology for data acquisition, which is the data extraction phase of the digital forensics lifecycle. We have performed multiple tests based on multiple criteria for open source tools that can be used to acquire disk and RAM images from IaaS deployed platforms. Then we have incorporated those tools into the new developed methodology. We took the methodology and we have applied it to a use case that we have pre-staged in the three major cloud providers that we've mentioned before, AWS, Azure, and Google Cloud, where we attempt to investigate criminal activity and collect some data and extract evidences correctly and present them for our fictitious court. Design and development. The artifact for this research is the forensics methodology or technique for acquiring data in public cloud using open source tools. We have spent most of our effort in developing the methodology and making sure that it covers the paces needed to deliver evidence that will be sound in courtrooms. Then we have spent a portion of this research time into testing all the available open source tools, and finally we toned them down to only 4 tools to be used in our methodology. The new methodology happened to have 6 phases. Those phases are maintain live acquisition mode, continuous login and accountability, integrity check for forensic tools, integrity check for the collected data, validation of the collected data, integrity and privacy checks for the data transfer. The paper goes into detail about each one of these phases, explaining why it's important and how are we proposing to implement this phase in this new methodology. Then the second part of the research, which is about 30% of it, is testing for forensic tools. And for our testing, we had to set of assertions that we have to vet these tools against. And down here we list some of them. First of all, the tool must be able to compile from source, should be maintained by a community, should be able to execute in an 86 or 64 architecture processors, should be able to capture raw data, it should be able to provide native hashing. Demonstration. For the demonstration purposes for our proposed methodology, we have created a fictional platform in AWS, GCP, and Azure, where we have created a web server. Then we have purposely made this web server vulnerable to an SQL injection attack. Then we carried that attack. We gained access to the server. We performed some malicious activities. Then we have used our methodology to try to collect data, analyze the data, and determine if we'll be able to backtrack those activities and collect evidences related to source IP addresses, what exactly the activities that were carried on this compromised server, and so on. Evaluation. The methodology have been evaluated based on the U.S. Department of Justice Electronic Crime Scene Investigations, a guide for list for the first responders. We have read this guide and we thought it has very solid basis to cover the production of a court-sought evidence. The integrity of the collected evidence were the main focus on this guide, then the authenticity of the collected evidence, and finally maintaining chain of custody from the generation of the evidence all the way to court. The tools testing side of the house, however, we have used the NIST CFIT framework that they use to test any new forensic tool. From the brief demonstration we have done, we have proven that the methodology was able to sustain and deliver evidences that can withhold scrutiny in court. Communication. We have found there are many research papers have been written and published that addresses various factors of digital forensics in the past 30 years. We have found no research related to open source being used for forensics or digital forensics, rather any research that focuses on forensics in the public cloud. This research can be published in the following journals and conferences: the IEEE International Workshop on Cloud Security and Forensics, the CTIN 2019 Digital Forensics Conference, the DFR-WS 2019, the ADFSL Conference on Digital Forensics, Security, and Law. This slide ends our presentation. I'll be happy to answer any questions you might have, and if you happen to need a copy of this paper, if you just email me at my DSW email, that is hossam.badruddin@trojans.dsu.edu. Thank you.